We live in an age of computation. It's all around us, silent and unseen, yet powering almost every aspect of our modern lives. From the tiny processors in our smartphones that connect us to the world, to the vast server farms that hold the collective knowledge of humanity, we are a species defined by our ability to process information. We have always been this way. Our journey began with simple tools, with counting on our fingers, with drawing lines in the sand. We craved patterns, we sought understanding, and we built machines to help us think bigger, faster, and more deeply than our own minds could manage alone. This desire is not just a modern phenomenon, it's actually a fundamental part of what makes us human. This relentless drive for more computational power is a story of ambition. It's a story of wanting to solve the biggest puzzles the universe has to offer. We want to predict the weather with perfect accuracy, not just for a day but for weeks and months ahead. We want to simulate the intricate dance of proteins folding inside our bodies to cure diseases that have plagued us for millennia. We dream of mapping the entire human brain, neuron by neuron, to understand the very nature of consciousness itself. These are not small tasks. They require a level of computational muscle that dwarfs anything we have today. The history of computing is a breathtaking acceleration. For thousands of years, our most advanced calculating device was the abacus. Then came mechanical calculators, clever contraptions of gears and levers that could perform calculations with the turn of a crank. The real revolution began in the 20th century with the advent of electronic computers. Machines like ENIAC, filling entire rooms with vacuum tubes and tangled wires. This incredible miniaturization was described by Moore's law today. We stand in the era of exascale computing. Our current computing paradigm is built on silicon. Transistors are now so small, just a few atoms across, that we're running into the strange and unpredictable rules of quantum mechanics. Electrons can tunnel through barriers they shouldn't be able to cross. Furthermore, packing so many components so tightly together generates an immense amount of waste heat, which is a major engineering challenge to manage. Every time your computer performs a calculation, it generates heat. This isn't a design flaw. It's actually a fundamental consequence of physics, dictated by the laws of thermodynamics. But our modern supercomputers perform quintillions of these calculations every single second. All of those tiny puffs of heat add up to a colossal thermal problem, a raging inferno on a microscopic scale. The world's most advanced supercomputers already require an enormous amount of infrastructure dedicated to just one thing: cooling. They need vast systems of liquid coolants. The answer to our energy crisis is staring us in the face. It's 93 million miles away, a gigantic ball of incandescent plasma we call the Sun. Our star is a natural fusion reactor of unimaginable scale. Every second, it fuses about 600 million tons of hydrogen into helium, converting the leftover mass into a blast of pure energy. In 1960, the physicist Freeman Dyson proposed a thought experiment. This megastructure, now known as a Dyson sphere, the Dyson sphere gives us the ultimate power source and the perfect radiator. The next logical step, the true leap in imagination, is to use that shell for computation. This first layer would be a colossal shell of what we might call computronium. The computations performed at this layer would be happening at an incredible speed. It radiates its waste heat away, just as our sun radiates its energy. This radiated heat is not a problem to be solved. It is the key to the next step. So this is where the concept gets its name. A Matrioshka doll, is a set of Russian nesting dolls. A Matrioshka brain applies the same principle to stellar-scale computing. The first innermost shell computes at a very high temperature, powered directly by the star. This energy is then captured by a second, larger shell built around the first. You could continue this process, adding more and more shells. The final, outermost shell would be vast, perhaps reaching the orbit of Mars or even Jupiter in our own solar system. Let's try to grasp the sheer scale of what we are talking about here. The total surface area available for computation would be billions of times the surface area of the entire Earth. The computational power of such an object would be truly godlike. It could simulate the entire history of the universe from the Big Bang to the present day. With a computer powered by an entire star, the question is no longer what you can compute, but what you choose to compute. A Matrioshka brain could possess enough computational power to model the behavior of every particle, every quantum interaction, The builders of the Matrioshka brain could run countless simulations, tweaking the fundamental constants of physics each time. What if gravity were slightly stronger? What if the speed of light were different? Another profound use for a Matrioshka brain would be to serve as an ultimate habitat, a digital promised land for its creators. An advanced civilization might choose to transcend these biological limitations by uploading their consciousnesses. They could shed their physical forms and become beings of pure information. The sheer scale of a Matrioshka brain means it could host an astronomical number of such minds. For a civilization that chooses to remain engaged with the physical universe, a Matrioshka brain would be the ultimate scientific instrument. Problems that are completely intractable for us today, like developing a unified theory of quantum gravity. It could design and control fleets of self-replicating probes to explore the universe, or carry out galactic-scale engineering projects, like rearranging star systems for maximum efficiency or safety. Our galaxy is vast and ancient. It contains hundreds of billions of stars. So, as the physicist Enrico Fermi famously asked during a lunchtime conversation, where is everybody? Our radio telescopes have been listening to the skies for decades, but all we hear is the quiet hum of cosmic background radiation. The concept of the Matrioshka brain offers a fascinating and perhaps unsettling new answer to this question. What if advanced civilizations don't expand outwards, but instead turn inwards? What if the ultimate goal of a mature intelligence isn't to colonize physical space, but to explore the infinite territory of computational space? If advanced civilizations are building Matrioshka brains, our current search for extraterrestrial intelligence, or SETI, might be looking for the wrong thing entirely. Instead of listening for signals, we should be looking for missing stars. More subtly, we could search for sources of excess infrared radiation with no visible star to explain them. These ghost stars would be the telltale heat signature of a stellar engine at work. The idea of Matrioshka brains forces us to fundamentally rethink what we are even looking for. But a civilization a billion years older than us might not be like us at all. The discovery of a Matrioshka brain would be a civilization-altering event. We wouldn't be meeting aliens, we would be discovering a god. The Matrioshka brain is more than just a piece of speculative engineering. It is a profound thought experiment. It acts as a mirror, reflecting our own civilization's deepest aspirations and anxieties. The Matrioshka brain suggests a future where the limitations that define us, aging, disease, scarcity, and even death itself, could be rendered obsolete, replaced by an existence within a boundless digital realm. The idea of Matrioshka brains paints a strange and haunting picture of the universe. It suggests that the cosmos might not be empty, but rather filled with silent, invisible superintelligences. This transforms our view of the night sky. When we look up at the countless points of light, we might not just be seeing stars. We may be living in a galaxy of ghosts and gods, ancient beings who have cloaked themselves from the universe. Contemplating a future that could lead to Matrioshka brains puts our own era into a humbling perspective. We are, by any measure, a species in its infancy. We are standing at the very beginning of a very long road. Then a future of almost unimaginable scope could lie before us. The universe is not a static place. It is a story that is constantly unfolding. They represent a fundamental shift in how we see the future of life and intelligence. This is a story that fills us with wonder. It re-enchants the cosmos, filling the silent void with the breathtaking possibility. The search for these marvels will continue. Our telescopes will get sharper. Each new discovery, each new planet found, each new cosmic mystery uncovered. We are explorers mapping an unknown territory. We are a product of the cosmos, a way for the universe to know itself. The Matrioshka brain is simply the latest, grandest expression of that ancient human impulse to look up at the heavens and wonder what lies beyond the horizon.